Alrighty, everybody. It looks like we just got our okay to start our planetarium show. So I put away our space trivia questions because now, folks, we're going to be heading into the unknown. And welcome, everybody, to the Morrison Planetarium. Really quickly, I just want to introduce myself. My name is Christian. I want to be your planetarium presenter. And just a heads up, I'm not just a voice coming out of the walls. I'm actually a person, and I'm standing right behind you. Hey, good afternoon, everybody. Don't hurt your necks, though. Look forward into the dome before you. Everything that you see in purple is going to be one really big screen, thanks to the help of 6 different projectors hidden throughout our planetarium dome. If you're looking for our projector system, it's hidden just below that purple glow. And also, folks, I'm happy to announce that the show that we're about to watch right now is by far my favorite to do because this show is called Tour of the Universe. And this show is completely live, so you're going to hear my voice for the next 30 minutes. And what it entails, well, we're going to be starting off pretty close to the Earth, and we're going to be zooming all the way out to the very edge of the observable universe. So hopefully by the end of the show, you won't have an existential crisis of where we are in space. But just a heads up, we're pretty small in the grand scheme of things, so just a forewarning. And before we get started with the show, I got to go over some quick house rules just so that we're all on the same page and have an enjoyable time. First off, folks, there's no food or drinks allowed in. If you brought any snacks, make sure those are put away till the end. Also, if you happen to have any cell phones, smartwatches, anything that produces really bright white light, now is a good time to put that away for the next 30 minutes as these can be very distracting. And folks, if you need to leave early, the exits are always going to be at the very top of the planetarium, so always make your way up the stairs to exit. And if climbing the stairs is a challenge for you because the stairs are steep, don't worry, just remain seated. Once the show's over, we'll have someone escort you to a lower exit as everybody else is going up to the stairs, so just stay seated for a bit longer. And last but not least, folks, this show can be quite immersive thanks to our 75-foot dome above us. If at any point during the show you start to feel overwhelmed, you start to experience motion sensitivity, there's a really quick and easy trick to ground yourself. All you have to do is close your eyes, take in a few big deep breaths, then your brain will remember that you're sitting in a planetarium in San Francisco and not hurtling across the universe, at least not more than the usual. But with that being said, it looks like we're ready to go. So I invite y'all to sit back, relax, and begin our tour of the universe. And let me just regain our controls here. Reorient ourselves. And like I said, folks, we're going to be starting off pretty close to the Earth. We can see the city lights just down below. But we're going to be starting off up here at this really cool spacecraft called the International Space Station, or the ISS for short. And a lot of people tend to ask me, hey, Christian, what is the International Space Station? I hear it all the time in the news and in articles, but I don't know what it is. Could you explain it for me? Well, of course, folks. The International Space Station is a research facility. It's a laboratory that orbits around our planet Earth. And they conduct all different types of science experiments up here. Things like what happens when you try to grow plants in space with less gravity, which way do the roots grow? Another one is what happens when you try to spark a match in space. Does the flame act the same? Does that act differently with less gravity? And one of my favorites is where they had 2 identical twins. One twin lived on Earth for about a year. The other one lived on the International Space Station for a year. After that year, they compared and contrasted the 2 twins. Turns out when you live in space for a long period of time, you tend to age a little bit slower. But not only that, you also lose a lot of body muscle because you don't have gravity constantly working down on your muscles all the time. So if you plan to live in space for a long period of time, remember to exercise daily. And folks, the International Space Station looks huge here in our planetarium dome, but it's not that big in actuality. It's only about the size of an American football field. If you've never been to an American football game, don't worry. You can also use the entire California Academy of Sciences, the museum we're sitting in right now. That's about how big it is. And also, folks, what's really impressive is that this thing is going incredibly fast. The International Space Station's traveling at a whopping 17,000 miles per hour, where it orbits once around the Earth every 90 minutes, and it experiences 16 sunrises and 16 sunsets a day. Whew, how romantic. And just to let you know, folks, the International Space Station looks pretty far away from our planet, but it's not too far away either. It's only about 225 miles above the surface of our world. 225 miles, that's like going from San Francisco to Santa Barbara, a nice little road trip to get away with the family for the weekend, so not too bad. But to tell you the truth, this is as far as we put humans into space nowadays, only 225 miles above the surface of our world. The reason why is because traveling into space is very expensive. You got to build yourself a rocket ship or buy yourself one or get a ride on one. And then you have to get so much rocket fuel, you got to be able to escape the Earth's gravity. And once you've done that, you have to account for all the food, water, all the air you're going to be breathing while you're up here in space. So the bill gets quite costly quite rapidly. But folks, the International Space Station is just the first stop on our tour of the universe. So now we're going to see it slowly fade away to the city lights down below. Looks like we're just above Italy, as we start to slowly see it disappear. In fact, before we lose track of the International Space Station, I want to add a nice little orbital path so we can keep track of it as it disappears to the lights down below. And now, folks, we're able to see our entire planet Earth from this point of view. And I want to let you know that the space program that I'm using here in the Morrison Planetarium is something that you can go home and download if you want to fly through space, just like how I'm doing right now. The space program that we're using in here is called OpenSpace. So if you go to your favorite search engine, type in OpenSpace project, you'll come across the link where you can download this and you can fly through space. But just to let you know, this space program is open source and it's in its beta phase. It's not completely finished. So we may come across a few bugs and glitches. If we do, I'll point them out. Hopefully we can look past them. And what's also really cool is that this uses almost real-time data information from satellites. So it uses a whole lot of processing power and information. So if you have an older computer, you may want to rethink it. It may overwhelm and take up too much space on your computer. But if you got something new or a gaming computer, give it a try. It's so much fun. But if you're a person like me that doesn't want to fly, doesn't want to download anything, or I just don't have enough space on my storage, we also have another great alternative called NASA's Eyes. Just like the human eyeball, type in NASA's Eyes, and you can fly through space without having to download anything, and it's so much fun. But in here, we're using OpenSpace. But now that we got a sense of what we're using in here, let's make our way over to our nearest natural neighbor to us in space, the moon. And folks, we humans have been to the moon before. That was between 1969 and 1972, thanks to NASA's 6 Apollo space missions that brought a total of 12 incredibly lucky guys to walk on the surface of the moon. They got to conduct science, and of course, they had some fun up here as well. They got to play some golf. But again, last time we sent humans to the moon was 1972, a little more than 50 years ago or so. But don't worry, folks, we humans are making a return trip back to the moon in the next few years, thanks to NASA's new space mission called Artemis. Pretty much with Artemis, NASA wants to send humans to Mars. But before we send humans deep into our solar system, we got to figure out exactly how we're going to be living out here in space. So the moon is the perfect stepping stone how we're going to figure that out. And what's really cool is that they're going to be sending the first woman to the moon, but not only that, they're also going to be sending the first person of color to the moon. But not only that, they're also going to be setting up lunar bases throughout our moon. Pretty much our technology has greatly improved in the last 50 years, and we're able to conduct much more science in a much more compactable size. And one place that we definitely want to set up a lunar base is the south pole of the moon. The reason why is because we found ice there, and ice is going to be very helpful because you can melt it, pass electricity through it, separate the oxygen and the hydrogen, and both of that stuff is very valuable when you're out here in space. But again, we humans should be heading back to the moon in the next few years. Just look out for any news about Artemis. And folks, when we look up at the moon here on planet Earth, sometimes it feels incredibly close to you. Feels like you can reach out your arms and touch it. But the moon's really far away. It's about 240,000 miles away from our planet Earth. Whew. 240,000 miles. Some of the adults in this room may have a car with that many miles on it. And if you take better care of your car than I do, you can even imagine driving to the moon if you drove for about 4 months nonstop, going about 80 miles per hour. Although I wouldn't recommend it, the roads out here are poorly maintained. Hee hee hee. And from here on out, folks, we're going to need to use a more useful measuring stick because at this scale, using miles is kind of like using inches to describe the distances between cities because space is so big. And astronomers use a more convenient measurement known as light speed. And light travels at a mind-boggling speed of 187,000 miles per second. That's roughly about 300,000 kilometers per second. So while it took the astronauts more than 3 days to reach the moon, traveling faster and farther than any human has done so or since, it only takes light 1.5 seconds to cross that distance at the speed of light. That's kind of like a short pause in conversation. But at last, folks, it's time for us to leave the moon behind. So everybody say bye-bye, moon. See you later. So cute. And now, folks, we're going to see the moon as it starts to slowly fade away, how we just saw with the International Space Station. And just like with the International Space Station, I want to add some nice planet trails so we can keep track of it, because, again, space is so big. And now we're going to see the moon's orbit and the Earth's orbit as it starts to slowly fade away. And folks, on our journey, we're going to be traveling much faster than the speed of light. We're going to be traveling at the speed of the human imagination, thanks to the help of computer models showing us the most accurate images and information available to us. And now, the nearest star to us, the sun, should be coming into view. So here comes the sun. Do-do-do-do-do. And also, folks, the sun is incredibly far away from us as well. It's about 93 million miles away from us. Whew, 93 million miles, that is a good distance. But in terms of speed of light, that's only about 8.5 minutes at the speed of light, so not too bad. And this is a really cool concept, because let's say the sun was to turn off all of a sudden, that last bit of sunlight will travel that 93 million miles to Earth, that 8.5 minutes at the speed of light, and then all of a sudden the daytime on Earth would become nighttime. And again, this is such a cool concept, because let's say we're looking at a star that's 70 light years away from us. We're looking at that star as it looked like 70 years ago in the past, because the light that just reached us took 70 years to get to us. So when you look at really far away objects in space, it's kind of like looking back in time in a sense, which is so cool. But now that we have a nice bird's eye perspective of our solar system, let's do a quick refresher. Right in the middle of our solar system, we have our star, the sun. Closest planet to the sun, we have Mercury. Then we have Venus, Earth, that's us, and then Mars, the red planet. These are all the rocky terrestrial planets. These are places where we can actually land a spacecraft on. And then past the orbit of Mars, we have this really cool thing called the main asteroid belt. This is where a majority of the asteroids reside. There is a lot of them. And then past the asteroid belt, we have the really big planets, the gas giants, the Jovians. We've got Jupiter, the largest of them all, Saturn, famous for its rings, and then we have our icy gas giants. We got Uranus, the funny one, and Neptune right over here. And of course, we can add everyone's favorite and lovable dwarf planet, Pluto. So here comes the orbit of Pluto on screen, just in the very top left right over there. And a lot of people don't realize that Pluto hangs out here in this outer part of our solar system called the Kuiper Belt. And you're probably wondering, what's the Kuiper Belt? I've never heard of that before. Well, folks, this is the Kuiper Belt. So way out here past the orbit of Neptune and where Pluto is the Kuiper Belt. And this is kind of like a second asteroid belt in the solar system. The only difference is that you're going to find icy asteroids here in short period comets that don't stray too far away from the sun. And what's really cool is that in 2006, our technology and telescopes improved so greatly that we were able to find more than 400 objects out here in the Kuiper Belt region. And folks, that was the day, those 400 objects, some of them were bigger than Pluto, and that was the day that all the astronomers across planet Earth had a great big meeting. They had to figure out what exactly you need to be considered a planet. And they came up with 3 different criteria that day. And folks, that was the day in 2006 that Pluto went from being a planet to a dwarf planet. And that's the really cool thing about science, because as our technology gets better and improves, we're able to see new stuff, and we're able to redefine and reclassify things. So science is constantly updating. So that's the really cool thing about it. But I'm going to put away the Kuiper Belt because that's just a whole lot to look at. And now I'm going to be adding on screen some of the many different spacecrafts we sent out in the 1970s to explore our solar system. So now on screen we have the trajectories of Pioneer 10, Pioneer 11, Voyager 1, and Voyager 2, and the latest of them all, New Horizons, which flew by Pluto in 2015. Now all of these spacecrafts are all traveling fast enough to escape the sun's gravity and leave our solar system behind. But even the most distant of these robot adventurers, Voyager 1, has not traveled as far as light travels in a single day. In order for sunlight to travel all the way out to the orbit of Pluto, it takes sunlight about 5 hours at the speed of light. Only 5 hours. Not too bad either. But now, folks, it's time for us to leave our planetary scale behind us because now we're going to be heading out into interstellar space, the space between the stars. Distance now becomes so immense, it's going to take us about 4 years at the speed of light just to reach the next star system to us, the Alpha Centauri system. And now all the way out here, our star becomes one of many stars in our star field here. And it looks like, let me just make sure I get the right one. Yes, that's it. So Alpha Centauri is going to be this star system just on the bottom right over here. We can see it moving much more than the other ones. And again, we're right in the center. That's our solar system. But again, 4 years at the speed of light just to reach the next star system to us, folks. But that doesn't put into perspective of how long it would take us humans to travel that distance. Folks, if you're getting a rocket ship today, left planet Earth, made your way over to Alpha Centauri, it's going to take you about 8,500 years to make that trip. Whew! And that's just a one-way trip. But let's stop consider whether humanity has made its presence known beyond our solar system, because now, folks, we're going to be stepping inside something called the radiosphere. And again, we're now inside something called the radiosphere, and this represents the current limits of the most distant radio signals humanity has ever broadcasted, or rather leaked into outer space. And it extends about 90 light years in all directions, emitting out from the Earth. This first began in the early 1930s with strong radio waves, early television, radar signal, and then later the detonation of atomic weapons. All this stuff is emitting electromagnetic radiation strong enough to escape the Earth's ionosphere. And humans were broadcasting well before that, but the earliest radio was not quite powerful enough to escape the Earth. Since all these signals are electromagnetic, they are traveling at the speed of light, so this is kind of like humanity's electromagnetic footprint in the universe. And of course, the radiosphere is constantly expanding at the rate of 1 light year per year, so is anybody out there listening? And now, folks, I'm going to be adding some many markers onto the screen. These many markers indicate many thousands of stars astronomers have discovered over the last 30 years, which has at least one or more planets orbiting around them. We call these planets exoplanets, and we're looking for any of them that are Earth-like with conditions suitable for life as we know it. So far today, we found more than 5,000 confirmed exoplanets in the nearby vicinity to us, 5,000 other worlds besides our own. And that 5,000 number is going to be increasing as the years continues because we have space telescopes where their whole purpose is to scan the night sky and find exoplanets, as many exoplanets as possible. In fact, you can see that we pointed our telescopes in this one direction of the night sky on the very top left of our dome, and we found a whole heap of exoplanets just in that one direction. So as it scans more and more, we'll be finding exoplanets left and right, so that 5,000 number will be increasing. Now, to say if any of them are Earth-like with conditions suitable for life as we know it, well, we cannot answer that question quite yet. Pretty much new space telescopes are being developed right now, so we've got a few years before those are launched into space and conducting science, so we got a while before we can answer the question. But the more important point here is that quite a few of these planetary systems are within that 90 light-year limit of our radiosphere, and they could have potentially received our signals. However, since radio waves travel at the speed of light, if there is anybody that's out there able to listen in and answer back, the communication delays between hellos could be decades in time. Now, to say, let's say we live in a star system, our solar system, over here on the left-hand side of our dome. We find an alien civilization somewhere on the right-hand side of the radiosphere. Let's say this over here. We shoot them a text message. We say, hey, we're humans. We live in this area of the space. Takes 60 years to get to the alien civilization. They answer back, and it takes another 60 years to get their message. Folks, that is a 120-year conversation in the making. Whew, and I could barely wait for a text message from my friend, so I don't know how this is going to happen. And of course, folks, planetary systems beyond the radiosphere more than 90 light years away have not heard from us yet, but eventually they will, as the radiosphere is always growing, but it becomes weaker as it does. And I want to put away our exoplanet markers for now, because as huge as, putting away the exoplanet markers for now, but I'm going to leave our radiosphere up on screen because as huge as humanity's electromagnetic footprint is, it is nothing compared to our Milky Way galaxy. Alrighty, folks, we're now looking down on our Milky Way galaxy, the galaxy that we live in. And I've got to ask, can anybody see their house from here? Just kidding, we're too far away. And folks, our galaxy is incredibly large. If you wanted to cross it from one side to the other, it's going to take you about 130,000 years at the speed of light to cross it once. This thing is huge. And our Milky Way is so huge, we estimate that there's at least 300 billion stars in our galaxy. If our recent discovery of so many exoplanets just within our small neighborhood and this vast star city is any indication, there could be potentially billions of planets and potentially millions of Earth-like planets throughout our single galaxy. And before we leave our Milky Way, I want to show you what it looks like from a sideways perspective. You're going to notice that our Milky Way is relatively flat, kind of looks like a big pancake or a frisbee in space. And this is important because when astronomers and scientists want to learn about the universe, it's so much more easier for them to point their telescopes galactically north and galactically south, instead of looking through the plane of our Milky Way, which has planets, stars, gas, debris, things that block their view of the universe. So just keep that in mind. That's going to come important just a little bit. We like to point our telescopes galactically north and galactically south. But folks, the Milky Way is only one of many hundreds of billions of galaxies that comprise the known universe. So in this giant leap, every single point of light that you're now going to see no longer represents a star, but rather the location of an individual galaxy. Each galaxy containing hundreds of billions, perhaps trillions of stars. And we live in a local galaxy group which contains about 30 galaxies large and small. Also includes the nearest large spiral to us, the Andromeda Galaxy. Only 2 million light years away, just next door and heading right for us. We're going to get to know it pretty intimately in about 5 billion years, so mark your calendars. And as we continue expanding out, folks, you're now going to realize that galaxies are not evenly distributed throughout space. Instead, galaxies like to clump together in large groups and clusters, or they create voids where there's very few galaxies or no galaxies at all. So we can see some nice galaxy clustering towards the center of our screen right over here. We can see some over here as well. We can see very few galaxies towards the top or no galaxies at the very top of our dome. So you can kind of think of galaxies like people. They like to hang out together or they like to avoid each other. And folks, the picture that we're now looking at represents the closest 30,000 galaxies to us in a space over 300 million light years across. We got to give thanks to an amazing astronomer by the name of Dr. Brent Tolley, who worked at the University of Hawaii, who compiled this amazing representation thanks to works of other astronomers working aside him over decades of time. So big shout out to Dr. Brent Tolley. I love flying through this galactic map. But now, folks, we have automated systems that are mapping to the most distant galaxies. So now we're about to see the very large-scale structure of the universe. And remember, folks, every single point of light that you're seeing that's not a star, that's an individual galaxy. And just a heads up, folks, the large-scale structure of the universe is not in the shape of a bow tie or a butterfly. Remember when I just mentioned that we live in a big flat spiral disk of our Milky Way? Well, if it were to line up our Milky Way galaxy, it would line up right down the middle just like so. And again, we like to point our telescopes galactically north and galactically south. But astronomers still want to make sure that there are still galaxies through the plane of our Milky Way. So we have this nice purple survey right here. You'll notice that they were still able to find galaxies, just not as many and not as far. Pretty much we have to wait for our technology to improve, and once that happens, we'll be able to fill in all these gaps that haven't been mapped out yet, so it's just a matter of time. But folks, we must continue pressing on because we're running close out of time on our tour of the universe. 30 minutes is just not enough time. So now we're going to be encountering these really distant, faraway objects known as the quasars. And the quasars are going to be represented by orange dots on either side of the large-scale structure of the universe. And the quasars are short for quasi-stellar radio sources. These blazing objects are all billions of light years away. So now we're looking so far back in the depth of time and space that the most distant quasars represent the universe at a much earlier age. We're nearing the very beginning of galaxy formation. In other words, with the quasars, we're viewing a sort of awkward, gawky teenage version of the universe. And before there was a teenager, there was a baby. So let's press back to a time before quasars, before planets, stars, and even galaxies began to form. Folks, we're about to see the very edge of the observable universe. And here we are, folks, at the very edge of the observable universe. And what we're looking at is something called the cosmic microwave background image, or the CMB image for short. And all evidence indicates that the universe that we live in is about 13.8 billion years old. This is data compiled by Planck and other radio telescopes. And the picture that we're looking at is a very baby version of the universe, only 380,000 years after the Big Bang occurred, where space and time began. And this isn't your typical photo either. Instead, this is a temperature density image, where the light echoes of the Big Bang are color-coded, with the lighter areas corresponding to the hottest, least dense regions, and the darker areas, the coolest, densest regions. And these fluctuations in temperature and density are extremely tiny. They vary no more than 1 part per 100,000, so really tiny differences. But these tiny differences eventually gave rise to that large-scale structure of the universe that we saw moments ago, that clumping and clustering of galaxies everywhere. Figuring out just how that happened is one of the larger challenges for cosmological research today. Though our view here is of the outer edge of the known universe, folks, the earliest light visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over billions of years of time. But folks, we've traveled as far back as the law of physics can physically allow us to go, so we only have one direction left to go. That's going to be back towards planet Earth, back home. So let's find a nice entry point through all these quasars and galaxies. And let me just put on one of my favorite tracks, and let's make our return trip back to planet Earth, everybody. All right, everybody, we're crossing an expanse of over 13 billion light years. We present you with this view of our universe and the latest in cosmological and astronomical information. We're covering eons and observing objects billions of light years apart. We live in a golden age of astronomy, with new generations of telescopes and spacecrafts that are extending the reaches of our eyes, preparing for the eventual race between the advancement of technology and the accelerating expansion of the universe. And with that thought, everybody, I want to remind you all that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauties and wonders of our universe. All you need is the night sky, and if you can, get away from the lights of our cities and look up. Even a good pair of binoculars makes for a decent first telescope, and there's astronomy clubs all around the world that invite you just to look through their telescopes and peer into the great beyond, allowing you to partake in the wonders that our universe has to offer. Now, astronomy as a hobby can offer an endless supply of satisfaction, and I do hope you'll join us, those who dream amongst the stars. But hey, look at that, we made our way back into our Milky Way galaxy. We're heading straight for that radiosphere. And of course, we're making our way back to our solar system, our star system, our little neighborhood in the vastness of space. And now, folks, we're about to pass those spacecrafts we sent out in the 1970s to explore our solar system, passing the orbit of Pluto in the Kuiper Belt region, making our way to the third rock from the sun, our homeworld, planet Earth. All the people that we know, love, ever learned about in history, all lived on this one planet. And now, folks, we're about to pass the orbit of the moon, the furthest we've ever sent humans out into outer space. And folks, as we make our final approach back to planet Earth, this is going to be the end of our Tour of the Universe show, and I want to thank y'all for stopping by and watching it with us today. If you want to share this show with some friends or family that weren't able to come and see the show today, you're always welcome to check out this exact show. We have it streamed on our on the Morrison Planetarium's Facebook page, or you can go to the California Academy of Sciences YouTube page, and you can find the show there. But otherwise, folks, we made it back home safe and sound, and that's all for today. We made it home just in time for dinner time, and I want to thank y'all for stopping by, and I hope you have a great rest of your night. Take care, everybody.